Hello everyone, welcome to my another new video. So basically you will see in my YouTube channel I have posted couple of videos on core Python concepts and also some videos of a powerful framework of Python, that is Django. So basically the beginning part of Django, I have provided few topics, uploaded few topics in the YouTube, but in case of core Python I have provided few concepts, couple of concepts. Okay, I have explained. Okay, so today's video is about explaining a different thing. Means though it is related to the core Python only, but of different thing, that is data structure. Okay, so how I will implement a concept of data structure in core Python. Okay, so basically now today I will explain how we will implement for particular search algorithm from a data structure, that is binary search. So in the right hand side you will see I have provided a handwritten logic of binary search. Okay, so that it is easier for all of you to understand how the binary search is working. Basically the use of binary search is, so when we have multiple, like an array of multiple items, suppose 1,000 items, a sorted array is there. Okay, so now if I use normal search algorithm or normal search method, then it will access each and every element and then it will search. Okay, but binary search, it does not do that. It is faster than linear search also, and in normal search also very faster. Why it is very faster? Because based on a particular midpoint it divides the array into two halves. Okay, and now it compares with the targeted value. So you will see, I will explain it. It compares with the targeted value, and if the targeted value is greater or lesser than the mid value, then according to that it will access, it will search in the left part or in the right part. Okay, then again this process will be continued in the left part or right part. Again it will be divided into two parts. Okay, so you will, so when I will explain the logic, I will understand what I am telling. Okay, so basically, so we start. Okay, so now the main concept, the main important thing we need to remember before implementing binary search is, that is binary search can only perform in a sorted array. Okay, binary search can only perform in a sorted array. If the array is unsorted, binary search cannot be performed. Second point is, binary search is faster than linear search. Okay, there are also many types of searching algorithms is there in DSA, that is selection search. Okay, uh, binary search, linear search is there, or multiple search algorithms is there. I will try to explain in my next videos. Okay, don't need to worry about that. So now basically the steps is, okay, now I will show you how the binary search is implemented, then I will explain you the code also. Now I will collapse the code. Basically I will explain the code also, and also I will execute this program, how the binary search is working I will show you. Okay, so now the steps is, first of all we need to have a key element and an array. Okay, basically in Python there is no array, in Java is array, but in Python there is no array. So we have implemented with the help of list only, but we can also create array with the help of NumPy library in Python. So in that way also you can do it at home or in your case. Okay, I have implemented it using list only. So now what we will see is that we need an array. So you will see in an array I have inserted 7 elements, sorry, 8 elements. Okay, and I have provided a key element. Okay, that is 16. Okay, so basically what I need to do, I need to find this 16. I need to check if this 16 element is present in the, in this list or not, or in this array or not. If it is present, then I want the index where it is present. Okay, okay, that will be performed by using binary search. Okay, so now how we will implement that? I have array and I have the key. Okay, now we will like create two reference variable. Okay, not two, three reference variable. First is low reference variable that will point to the first index of the array. Okay, means it will not store the value of the index, it will store the index value. Okay, means low equals to 0, it will point to the low. it will point to the zeroth index. Now another reference variable is high, that will point to the last element, okay, last index, okay, that is 7. And now what I need to do for implementing binary search, we need to find the middle element, okay. So how the middle element will be, we will get, to find the middle element we have to add the lower index and the higher index, and we will divide by 2, then we can get the middle element, okay. So basically the low will point to the zeroth index means 0, and high pointing to the last index means 7. So 0 plus 7 by 2 equals to 3. So 3 will be, third index will be our middle index, okay, middle index, third index where my middle, like mid reference variable will point to, okay. So now mid is point to the third index, and it is like where 12 is stored, okay. So now after that it will check if the mid element value is same as key value. No, reference value stored in the reference variable key, is that same, 12 and 16 same? No. If it is same, then it will return the mid. We have got the searched item, so it will return the index. But it is not true, it is not same, so that's why it will not return anything, okay. I will show you. See here, if I expand the binary search function, I have implemented through oops concept means class and object, okay. So basically what I have done, low, yes, low I have initialized with 0 means it points to the 0th index, and high will point to the 7th index means last index, length of array minus 1, okay, that will be the same. Now I am checking if low is lesser than n. Basically the low will be lesser than n, low is pointing to the first element means 0, and high is pointing to the 7th index, okay, means high, so lesser than equals to low. Now I am finding the mid element. How we will find the mid element? I have shown you low plus high by 2 divided by 2. We will go to the mid element, okay, means mid is pointing to the 3 now, okay. Now it will check, see, if array like mid element is greater than lesser than x, means here x means the key, okay. If array element is lesser than 16, no, array element is lesser than 6, yes, array element is lesser than, it will know if both the if and else if condition will be false, then it will return min. If 16 and 12 will be equal, then it will return min. We have got the index, the value is searched, but not there. So what it will do, it will compare. See, I have written here also in the second step, okay, what I have written, key value is greater than mid value, so that means mid is smaller than key, so that means the value will be searched in the right hand side, okay. See, search in the right half, value will be searched in the right half, okay. Or else if the mid value is greater than, so if the mid value is greater than key, then the key will be lower, smaller than mid, means the value will be maybe in the left hand side, maybe in the left hand part, okay. So we will search in the left hand part, but here in this case mid is smaller than key, so that means we have to find search in the right hand side. So now what it will do, now here see x is greater than mid, so what I will do, so what it will do, so now low equals to mid part 1, means low is now pointing to this index after mid, what mid is pointing. Now see, low is pointing to the fourth index, see, low is pointing to the fourth index in the start search set, okay. Now and high will be as it is, so this case is not true, that means high will be as it is, okay. Now here also same process will be continued, okay. So what it will, again the mid value is will be searched, okay. So how the mid value will be searched, low is pointing to 4 and mid is pointing to 7, okay. So now 11 by 2 means 5. Now mid point to the in the 5 index, points to the 5 index, there is 23. Now again it will search if 23 is equals to 16, no, 23 not equals to 16, so that means it will not return, else part will not be executed. Now it will check the if part, if mid element is lesser than x, lesser than key, mid element 23 is lesser than key, no, in this case L if condition will be true, mid element is greater than key, that means the value may be present in the left hand side. If key is smaller, search in the left hand side, value will be sent in, value will maybe in left hand side, that means now what it will do, it will do the high equals to mid minus 1, means the high is now not pointing to the 7 index, it will point to the before index where mid is pointed. Okay, means mid minus 1 means it will point to the 4 only. Now lower part will also point to the 4, higher part will also point to the 4, and if I go for searching the mid element here also, then low plus high, 4 plus 4 by 2, 8, 8 by 2 equals to 4. Now mid is also pointing to the fourth element, fourth index. Now it will check if the mid element is equals to key or not. Now in this case else part will be executed because key and mid element is now same, 16 and 16. So that's why it returned the mid, means it is found at index, the index will be returned, mid means the index will be returned. Now it will found at index 4. In this way binary search performs. Now I will show you the execution. Okay, first of all I go to the main part and I've created a list. Okay, and I've taken the range as user input, and till this range the for loop will run and I am appending the elements into the list. Okay, but there is a one main condition before implementing binary search, that is the array should be sorted. Okay, so now I have printed the sorted array also. When I will execute this file you will see it. Okay, now I will take the key, means the targeted input, like the value which I need to search, I will take it also as an user input. Now I have created an instance of the class search operation. Okay, and with that reference I have called the binary search. Okay, if I does not call the function, then how the binary search logic will be implemented. Okay, now it is returning what, -1, or it is returning like based on the condition it is returning different values. Okay, based on the condition returning different values, so that's why that result, that value will be stored in the result. So that's why result is of type class, will store the object of type class int. Okay, now what I am doing basically, now if the item is not found, okay, if the item is not found, then it will return -1, the function will return -1. So now I'm checking if result is not equals to -1. Okay, if result equals to -1, then the item is not found, element is not present in an array. But if the element is not -1, then element is found at index, I'm printing the result, which index. Okay, so now if I going to execute it, suppose where is my terminal, here is my terminal. If I going to execute it, suppose Python and with the file name, if I get into, and I will give this element only, there are 8 elements, suppose I will give the range 8. Okay, now element 1 is 2, second element is 5, third element is 8, fourth element is 12, fifth element is 16, sixth element is 23, seventh element is 38, and eighth element is 56. Now I will give, if I press enter, the sorted array is printed. Now I want to search which, the key will be 16, so I want to search 16. It will return found at index 4. It will return index 4. If I press enter, see, element is present at index 4. So I have explained you the approach how binary search searches an element in an array. Okay, so in the next video, up to this this video will be, so in the next video I will try to explain another type of binary search, that is recursive binary search, where we will, in this part, in this function, like after the condition we will return the function itself. Okay, I will execute the function itself, that I need to, that I will try to explain in my next video. And also don't need to worry about that, because I will explain the other sorting algorithms and searching algorithms also. So like I've explained the first concept of data structure. Okay, so if you have any questions and any doubt, you can know me in comments, I will definitely reply to it. So that's all, thank you and bye bye till my next video came. Okay, so bye bye.